good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. We are still dealing with rational expressions, but we have to include something that's called direct and inverse variation. Okay? Direct and inverse variation is very, very simple and at the same time very difficult. It really depends on how you see it, and it depends on how well you read things and how well you follow directions. So I am hoping and anticipating that you will perform well in this. It's a very important skill. I've seen it many SATs and ACTs. It happens a lot. It is a very word problem intensive skill. But I'm going to show you how to set this up so you can solve any word problem that involves direct or inverse variation. So let's get right to it. The time it takes to hear thunder varies directly with the distance from lightning. It's modeled by the following function. Y equals 1/5 x, where y in this particular case, the distance in miles, the lightning is, and x is the time it takes to hear the thunder. This is what's called a direct variation. I have seen it in books. Sometimes instead of saying it varies directly, sometimes they'll tell you that they are directly proportional. That's the same exact thing. I don't want you to get confused. If they tell you something varies directly with something else, or something is directly proportional to something else, that means that they're talking about direct variation. Now, what does this mean? A direct variation is a function where you just have something being multiplied to the x. Nothing is being added to the x, nothing is being subtracted to the x. In this particular case, 1/5 is being multiplied to x. That's a direct variation. Why is it called direct variation? Because whatever x is, I have to multiply it by 1/5 to get y. So y is always, in this particular case, 1/5 of x. It's a direct proportion. That's why it varies directly. Okay? When you have direct variation, it is a relationship that can be represented by the function in the form of y equals kx. K is very important, and that is the key to every single direct and inverse proportion or inverse proportion or variation problem. K is the key. K is the constant of variation. That is the one thing that is constant always. It never changes. In this example up here, the 1/5 is constant. It doesn't matter if x, which is the time, is 5 seconds, 50 seconds, or 5,000 seconds. That 1/5 is constant. The distance varies directly by 1/5 of x. So that constant of variation is what's constant there. The x is independent. The y depends on the x. How does it depend on the x? It depends on the k. K determines how y is affected for any change in x. Now, in order to find your k, you can simply divide x to both sides, and k equals y over x. A lot of times, people don't want to memorize both formulas, which I totally get and understand. So be able to manipulate this formula, though. If I have y equals kx, you have to be able to say, okay, divide by x, all right, k equals y over x. After you work with it a bunch of times, you're going to eventually memorize it. But if you don't want to expend that energy on memorizing another equation, that's cool. You have to memorize the direct variation, though. You have to. And then from there, you can solve for k. All right? So x is independent, y is dependent, and k is the constant of variation. It is the coefficient of x. It is the number being multiplied to x. Now, you can determine whether an equation represents a direct variation, comma, okay, just by solving it for y. If you can write the equation in the form y equals kx, where k is not 0, it represents a direct variation. So if I have anything being added to or subtracted from x or y, that is not going to be a direct variation. Direct variation concept summary. Y varies directly with x. That means that when the function is in the form of y equals kx, I have a direct variation. What's happening here is when x increases, y will increase by the same factor. When x decreases, y will decrease by the same factor. When the k is constant, so it remains the same for every point x and y. That constant is the same factor that y changes depending on x. It changes by a factor of k. That is your constant of variation. So, first step here. Does the equation represent a direct variation? If so, find the constant of variation. Okay. In order to do this, you solve for y and see if it comes out in a direct variation form. Here I would divide by 7, y equals 2/7 x. Is that a direct variation? Yes. Just for giggles, what's the k? What's the constant of variation? Very good. Okay, here, C. I subtract 4x on both sides. 5y equals negative 4x divided by 5. Y equals negative 4/5 x. Is that a direct variation? Yes, it is. Right here, right off the bat, I can tell immediately it's not going to be a direct variation because of that 8. But I'll prove it. Subtract 4x on both sides. I got 3y equals negative 4x plus 8 divided by 3. So y equals negative 4/3 x plus 8/3. This is not a direct variation. Why is it not a direct variation, guys? Thank you. Because of this 8/3 here when I solve for y. Or because of originally that 8 that was there. You know it's going to be added to the x, and that can't happen. Letter D, do I even have to solve for y here? No. I mean, if I divide by negative 3 to everything, I get y equals negative 2x plus 3. That 3 makes it not a direct variation. Does that make sense to every single human in this class right now, guys? I need honesty. I cannot move forward without honesty. Everyone can recognize the direct variation. It's in the y equals kx form. Okay, so again, does anyone have any questions as to how to recognize a direct variation? Going once, twice, sold for $1. Okay, now, let's see how we can apply this. Suppose y varies directly. Ding, 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 ding. That should be immediately an indicator for you. Okay, it varies directly with x. So I know that I have a y equals kx function. Why, Mr. Morrow? Because varies directly, that is a y equals kx. When it's directly proportional or it varies directly, it's y equals kx. So right off the bat, this is what always saves me. I set up the function without any numbers, but I know that this varies directly, so it's a y equals kx. Okay? And y equals 35 when x equals 5. What direct variation equation relates x and y, and what is the value of y when x equals 9? So basically here, I got to use what they gave me to find k, then rewrite the function with the proper k, then plug in and solve for what I need to solve for. So they tell you that y is 35. That equals k times x, which they say is 5. So I divide by 5 to both sides, so k equals 7. Now my function is y equals k, which is 7x. That's my function. Now that I have my direct variation function, now I can plug in, gentlemen, and find y. What is the value of y when x is 9? Well, thank you very much, my brother. Y equals 7 times 9, so y equals 63. So there were 3 steps to this, gentlemen. Number 1, set up the type of proportion that you were given. Number 2, plug in and find k. Number 3, write the function. Number 4, plug in the values they give you and solve for the variable you're looking for. Questions, comments, concerns, problems, issues, confusions. Now would be a wonderful time to ask. This is my job. This is what I'm here for, guys. Please. No? Still my brother. I'm sorry, my man? Not necessarily. No, I don't know where we isolated. It's not that we're isolating the y value. It's that we're writing a function in the form of y equals kx. And then I plugged in the y that was given to me, the x that was given to me, and then I solved for k. Now that I have k, I'm going to plug that k into this function right here. Y equals k, which is 7, times x. So I don't know what you mean by isolate the y value. Well, the problems above, with all due respect, we did that a while ago, and that's why I asked you during example 1 to ask questions. Okay, but now that we're here, back in example 1, yes, in order to determine if it's a direct variation, sir, you must solve for y. If it is in y equals kx format, or form, comma, then it is a direct variation. Does that make sense, son? Are you sure, my man? Because I don't want to go backwards anymore. You promise. Thank you, sir. For example 2, does anyone have any questions on example 2? Okay, thank you, gentlemen. Let's go to example 3. Suppose y varies directly with x. Ding, 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 ding. That's your key right there. Varies directly. So y equals kx. We know that much. And y equals 10 when x is negative 2. What direct variation equation relates x and y? And what is the value of y when x is negative 15? Well, they're telling me that when y is 10, x is negative 2. Divide by negative 2, I just found my k, which is negative 5. Now that I found my k, plug it into the function. Y equals k, which is negative 5 times x. Now that I have my function with my proper k, plug in what they gave you and solve for what they want. So y, what is y when x is negative 15? Well, I got negative 5, which is k, times negative 15. So y equals 75. Questions, comments, concerns, problems, anything at all? Let me know, please, gentlemen, because I'm not going to go back to this. Please let me know now. Okay, thank you. Now, remember that if the constant of variation k is the same for each pair of data, the relation has to be a direct variation. Sometimes they're going to give you tables, and they're going to say, does this represent a direct variation? Okay? The only way you could tell is by comparing the k's. Remember that in a direct variation, y equals kx. The k is constant. So it doesn't matter how many values of x and y you have, the k is always constant. Remember that in order to find the k equals y divided by x. Just simply solve for k. So in order to test to see if a table of values, a relation, is a direct variation, you must find the k for every x and y value. If it is constant, it's a direct variation. If it is not constant, then it is not a direct variation. So y over 4, that's 6, y over x, that's 6/4, which is 3/2. That's my k there. Y divided by x, that's 12 over 8, divide by 4, so that's 3/2 as well, that's my k. And 15 over 10, y divided by x, that also is 3/2. Is the k constant here? Is this a direct variation here? Yes. Just for giggles, what would the function look like? Y equals 3/2 x. Thank you, because that's my k. Beautiful. Next. I don't know if you could see this, but those are decimals. All right, let's do it like that. Okay. So I've got y over x. That's going to give me my k. So 3.2 divided by -2 is -1.6. That would be my k there. 2.4 divided by 1 equals 2.4. I can stop right here immediately. No, it is not a direct variation. Why, Mr. Morrow? Because the k was not constant. If the k is not constant, then you do not have a direct variation. Next, remember that k equals y over x. So 2.25 divided by -3, believe it or not, is -0.75. -0.75 divided by 1 is still -0.75. So that's my k. That's my k. And then -3/4 is -0.75, which is my k. So all the k's are constant. So this is a yes. And just for giggles, what would my function be? Y equals k, which is -0.75 x. Very good. Does that make sense to everybody? Are you sure? Please ask me now, gentlemen. I'm here to help you. This is my job. This is my duty, and this is my pleasure. Talk to me. Okay. Now, inverse variation. The good news, exact same procedures. The only difference is that the function is a little bit different. When you have direct variation, the k is being multiplied to x, or rather the x is being multiplied to k. When you have inverse variation, sometimes, just so you know, in word problems they'll say inversely proportional to. So if they say directly proportional, that's direct variation. If they say inversely proportional, that's inverse variation. And an inverse variation is y equals k divided by x. If I went ahead and solved for k here, that means that I would multiply x to both sides. Okay? And if I multiply x to both sides, I will have the following. Okay, so inversely proportional or inverse variation. It's when y equals k over x. If I solve for k, I multiply x to both sides, k equals yx. Again, you don't have to multiply, memorize another two equations. All you got to do is memorize this guy and know how to solve for k by multiplying x to both sides. Okay? Now, everything works the same with inverse variation, except it's y equals k over x. Now, last but not least, you can combine this direct variation and inverse variation into what's called joint and compound variation. Joint variation occurs when several factors are being multiplied to the k. So you can have y equals kx, z, w, whatever. When you're multiplying factors to the k, that's called joint variation. It's just multiplying. Combined variation occurs when k is being both multiplied and divided by different factors. So combined variation is a direct variation because you have something being multiplied to the k, but it's also an inverse variation because you have something being divided to that k. Please be careful with this. This is where the majority of word problems come from. They use joint and combined variation. Are you with me so far? Any questions so far before we get to it? Okay, I tried. So let's try this. The weight W can be safely supported by a 2-inch by 4-inch piece of lumber, varies inversely with its length. Ding, 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 ding. Varies inversely. So the weight W that can be safely supported by a 2 by 4-inch piece of lumber varies inversely with the length L. Experiments indicate that maximum weight a 12-foot pine 2 by 4 can support is 400 pounds. Find a function that relates the maximum weight to the length L for any pine 2 by 4. Okay. They give you the clue right here. It varies inversely. So the weight W can safely be supported by a 2-inch 2 by 4 piece of lumber, varies inversely, so K over L, the length. I'm going to stop right there because if you don't know how to do that first part, the rest just is literally almost impossible. Does everyone see how I got that from that first statement right up here? The weight W can be safely supported by a 2 by 4 piece of lumber, varies inversely with its length. Yes?
Is the length of the bottom being x because it's what you're looking at?
It's L now. There is no X or Y in this particular case. You have W varies inversely with L. Remember what we said with inversely. You're dividing whatever variable that is to K. So it's K over L. So yes, this could have been like this, but I'm not going to use Y and X because I don't have a Y here. I have a W. I'm not going to use an X. I have an L. Thank you so much, sir. Great question. Very proud of you. So that's my model function, but I don't have any numbers yet. So let's look at A. Experiments indicate that the maximum weight, a 12-foot pine 2 by 4 can support is 400 pounds. Find a function that relates the maximum weight to the length L for any pine 2 by 4. Well, let's do this. What did they say my W, my weight was? 400. I'm looking for K. What did they say my L, my length was? 12 feet. So what's my K, gentlemen? 4,800. So what's my function, gentlemen? W equals K, which is 4,800, over L. Okay, I only had 2 people answer that. Where are we getting confused? Talk to me, please, because you told me you understood it, and right now I saw that many people did not understand that. I'm here to help. How can I help you guys? You set up the function, W equals K over L, because it was inversely proportional. It varies inversely. Then I plugged in my W and my L to find my K. Once I have my K, don't I plug the K into this function that I started with, guys? Hello, guys, talk to me, please. Okay? Then B. Determine the maximum weight a 15-foot pine 2x4 can sustain? Okay, well, W equals 4,800 divided by L, which is 15. So what would the weight be there? 4,800 divided by 15, 320 pounds. You're going to have a bunch of these on the quiz and on the test. Yes, sir. Units, yes. You have to worry about units, of course. Because we're in math, my brother. I'm not trying to be sarcastic, but 320 what? Pieces of paper, cupcakes, cookies, cars, bicycles, inches, miles, meters. Okay, I'm not trying to be sarcastic, but that's the point. Okay, you gotta label. Thank you so much for asking. God bless you. Okay, number 5. Determine whether the given relation is a direct variation, inverse variation, or neither. Well, let's see. If it's a direct variation, what does k have to equal? What does k equal? Y over x. Very good. If it's an inverse variation, what does k equal in an inverse variation? Y times x. So let's see. Let's test first for direct, and then we'll test for inverse. 15 divided by 2. Well, that's 7.5. 7.5 divided by 4 is not 7.5. So is this direct variation? No, it's not direct. Let's try it, see if it's inverse. 15 times 2 is 30. So k equals 30 here. 7.5 times 4 is 30. So k equals 30. 3 times 10 is 30. So k equals 30. 2 times 15 is 30. So k equals 30. So what kind of the k is all constant, but what kind of k do we have here? An inverse variation. So this is an inverse variation function. And what is the function itself here, gentlemen? If I know my k already, it's inverse variation. Y equals 30 over x. Very good. Awesome. Questions, comments, concerns, problems, issues, dilemmas. Talk to me, brothers. Please. No? We're good? Promise? All right, let's see how much you promise. Let's see. Let's see if you guys are lying to me or not. Suppose that x and y vary inversely. Ding, 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 ding. That's it. I'm doing this on purpose, guys. I'm not trying to be an idiot up here. That's the key. It told you right there immediately, inversely. So right off the bat, I know that y equals k over x. I don't know what the k is, but I know that y equals k over x is the function here because x and y vary inversely. Okay? They're inversely proportional. So when x is 4, when y is 12. So 12 equals k over x. And x is 4. So k over 4. What does k equal? 48. Very good. So what is the function? What function models this inverse variation? Y equals 48 over x. Now, it doesn't matter what the x is. I plug in the x and I find what y is. Does this make sense, gentlemen? All right. Now, let's look at number 7. This is the type of thing you're going to see in your homework. This is the real type of equations that or word problems you're going to see on quizzes and tests. This is an SAT type of word problem. A lot of words. They're trying to confuse you. If you follow my guide, you follow my rules, they can't confuse you. The force F of wind on a flat surface positioned at a right angle to the direction of the wind varies jointly with the area of the surface and the square of the speed v of the wind. Stop. Varies jointly. So does that mean that I'm multiplying different things to k or dividing? Very good. So the force F varies jointly with the area A of the surface and the square of the speed v. So that would be v squared. I'm going to stop right there because that's what I would normally do if I was solving this problem on my own. I first go ahead and check everything out. I write down the function that I'm going to use. Does everyone understand that first step? Okay, next. Now let's plug in. Okay, I have a wind of 30 miles per hour. So it's just 30 squared. Not because I'm so smart, but because I read. Speed v of the wind. Okay? 30 miles per hour, blowing on a window measuring 4 by 5 feet. So what's the area? 20. Has a force factor of 150 pounds. So this is 150. I'm going to stop right here. Does everyone see what I just did there? Promise. Okay. So 30 squared is 900. 900 times 20 is, I think, no, 900 times 2 is 1800. This would be 18,000. So 20 times 900, let me just make sure. Yeah, that's 18,000. So I got 150 equals K times 18,000 divided by 18,000. Cancels. K equals 15 over 1800. But we know how to, or we should know how to reduce. What goes into 15 and 1800? How about something a little bit more significant? Okay, we'll go, 15 can go into it, yeah. 15, no, 30 doesn't go into 15. But thank you for trying at least and caring. So we divide this by, so this is by 15. Come again, son?
Oh, wait, never mind.
Okay, thanks. So that equals K. K is 1 over 1/20. So that's my K. But now, what do I do with that K? Well, I know, thank you, my brothers. Force equals K, which is 120, times A times velocity squared. Now, what is the force on a window measuring 2 by 6, so my area is 12, caused by a hurricane force wind of 100 miles per hour. So we got 100 squared. Okay? So here, just doing simple math, 12 divided by 120, that'd be 1/10, correct? And then 100 squared would be 10,000. Cancel out one of the zeros, so my force would be 1,000 pounds. That's going to be the norm. That's going to be the majority of the kind of questions you'll see in quizzes, tests, and SATs and ACTs. Does that make sense, gentlemen? Okay. Last but not least, the electrical resistance of a wire R, so R, varies directly with the length of the wire L, so it varies directly with L, and inversely with the square of the diameter of the wire D. Inversely with the square of D. So you see how all those words are very simply put into this function, guys. You just got to know what varies directly and varies inversely means. If a wire 432 feet long, that's my L, so I've got 432, and a 4-meter diameter, so 4 squared is 16, has a resistance of 1.24 ohms, that's my resistance. Find the resistance in a wire that is 282 feet long with a diameter of 3 meters. I can't find anything until I solve for K. So I've got 1.24 times 16. That gives me 19.84. That equals 432K. Divide by 432 to both sides. And K will equal 0.0459. Let's go ahead and round to 0.046. In a situation like this, of course, you will be able to use a calculator, but your calculator will render you worthless unless you know what you're doing, okay? Now that I have K, I can write my function. R equals K, which is 0.046 times L divided by D squared. Now let's plug it in and find what I'm looking for. Find the resistance R in a wire that is 282 feet long, so 0.046 times 282, with a diameter of 3 meters. 3 squared is 9. Now it's just math. So you got 0.046 times 282 divided by 9. My resistance will equal 1.44 ohms. How do you know ohms? Because I read. And that's that. Questions, comments, concerns, my brothers? Okay. Remember, I'm here in the morning and after school for you. Thank you very much. God bless you, and I hope you learned a lot. Have a great day.